All right, so last type of bond are metallic bonds. So here's a tungsten filament with a light bulb. From a light bulb was taken the scanning electron microscope. The filament is magnified more than 100 times. The diameter of the wire is about 15 micrometers or 0.0015 centimeters. One challenge for researchers about the year 1900 was to find the best material for the filaments in light bulbs. The substance, one, had to be ductile enough to be drawn into a narrow wire, so it had to be easily shapen. Two, could not melt at the temperatures produced when electric current passes through a narrow wire, so it had to have a really high melting point. And three, it had to have a low vapor pressure so that particles on the surface were not easily removed by sublimation. So a lot of specific things that they're looking for to find in this material. The substance the researchers found was tungsten. It's W on the periodic table, which stands for wolfram. It's German. A metal whose name means heavy stone in Swedish. Like most metals, tungsten is ductile. Tungsten has the highest melting point of any metal, 310 degrees Celsius, and two, tungsten has the lowest vapor pressure. So that was their choice. What are the forces that give a metal its structure as a solid? The cations in the metal form a lattice that is held in place by strong metallic bonds between the cations and the surrounding valence electrons. Metal atoms achieve stable electron configurations by losing electrons. What happens if there are no nonmetal atoms available to accept the electrons? In a metal, valence electrons are free to move among the atoms. In effect, the metal atoms become cations surrounded by a pool of shared electrons. A metallic bond is the attraction between a metal cation and the shared electrons that surround it. Although the electrons are moving among the atoms, the total number of electrons does not change, so overall the metal is still neutral. The more valence electrons an atom can contribute to the shared pool, the stronger the metallic bonds will be. The bonds in an alkali metal are relatively weak because alkali metals contribute only a single valence electron. Sodium is soft enough to cut with a knife and melts at 97.8 degrees Celsius. But like we just said, transition metals such as tungsten have more valence electrons to contribute. Therefore, tungsten is a hard metal that melts at 3,410 degrees Celsius. So more electrons, higher the melting point. How do metallic bonds produce some of the typical properties of metals? The mobility of electrons within a metal lattice explains some of the properties of metals. The mobility of electrons within metals affects the properties. The ability to conduct an electric current and malleability are two important properties of metals. A metal has a built-in supply of charged particles that can flow. An electric current can be carried through a metal by the free flow of the shared electrons. In a metal, cations are surrounded by shared valence electrons. If a metal is struck, the ions move to new positions, but the ions are still surrounded by electrons. So when you have a piece of metal and you hit it with the hammer, the electrons can get themselves back into place. The metal changes shape, but does not break, again, because of the mobility of the electrons. How are properties of alloys controlled? Scientists can design alloys with specific properties by varying the types and amounts of elements in an alloy. An alloy is a mixture of two or more elements, at least one of which is a metal. Alloys have the characteristic properties of metals. The surface of an object made from pure gold can easily be worn away by contact with other objects, or dented because gold is a soft metal. When silver, copper, nickel, or zinc is mixed with gold, the gold is harder and more resistant to wear. These gold mixtures are alloys. That's why anything that's pure gold, you probably won't get your hands on. It'll probably have something mixed with it. Copper alloys. The first important alloy was bronze. In its simplest form, bronze contains only copper and tin, which are relatively soft metals. Mixed together in bronze, the metals are much harder and stronger than either metal alone. Bronze is hard and durable enough to be used for propellers on ships and for statues such as these statues of horses. The French horn is made of brass, an alloy of copper and zinc. Although both bronze and brass are alloys of copper, they have distinctly different properties. Brass is softer than bronze and is easier to shape. Brass is shinier than bronze, but is likely to weather more quickly. A bronze bell has a clear, loud tone that lasts for several seconds. A brass bell has a duller tone that dies away quickly. Steel alloys. Steel is an alloy of iron that contains small quantities of carbon ranging from less than 0.2% to about 3% by mass. The smaller carbon atoms fit in the spaces between the larger iron atoms and the lattice. The carbon atoms form bonds with neighboring iron atoms. These bonds make the lattice harder and stronger than a lattice that contains only iron. The properties of steel depend on which elements in addition to iron and carbon are used to make the steel, and how much of those elements are included. Stainless steels contain more than 10% chromium by mass, but almost no carbon. Stainless steels are durable and do not rust. Stainless steels are more brittle than steels with more carbon. The cables, towers, and deck of the Golden Gate Bridge contain steel. The steel in the cables needs to resist forces that pull on the cables. The steel towers need to resist the compression forces caused by the weight they hold. So these are steel cables, but they need to be able to stretch just a little bit. They got to have a little bit of leeway. Other alloys. The body of a plane is large and needs to be made from a lightweight material. Aluminum is lighter than most metals, but pure aluminum bends and dents too easily. Copper or manganese is added to aluminum to make it a stronger material that is still lighter than steel. For some parts, even lighter materials are needed. Alloys of aluminum and magnesium are used for these parts.